May I use this?
Yes.
Okay, hello everyone. Yay! Yeah, this is the first time to visit Malaysia for me. So thank you for giving a chance to meet you and introduce about the JAX and others. So today we will just cover some short story about the Keras Core and also just dig slightly about the JAX. So before starting, I will just introduce about myself. I'm Jeongkyu Shin. Just call me Shin because Jeongkyu is hard to pronunciate. Yeah. So I'm just working on lab pipeline up. Yeah, finishing. So we are making the backend of the AI platform, which is the clustering platform for the machine learning. So it's just powering up many cloud service and machine learning and deep learning backend, and it generates many models. So if you are using the Samsung Galaxy smartphone, you are also using the models built on the backend of the AI. And also, as the machine learning Google developer expert, I work on there from 2017. Yeah, so quite long way, huh? And now working as a cloud champion innovator and also startup accelerator mentor. And also, I Test Cube open source project. This is a blog platform, so you are also known as the blogger.com for Google service. Yeah, I got a PhD in complex system and computational neuroscience. So I modeled the feed neural network. Yeah, at the time, yeah, there is no toolkit or some cafe-like tools. So we had to make our own neural net with a C++. Yeah, old times. Yeah, at the time, my professors really concerned about me because he believed that I will starve after I graduate because there is no way to use the machine learning or deep learning or neural net in the field. Maybe it's 20, almost 13, yeah, 10, 11 years ago. Yeah, there is no way to use the machine learning or deep learning on the field. Yeah, everyone just use the C++, and there is a cafe. So it's a kind of breakthrough, and also Theano is a breakthrough, but there is no way to apply as an application nowadays, like nowadays. Anyway, yeah, sorry. Yeah, I just worked adjunct professor in the software development too. Yeah, this is the backend of AI. So let's start from the Keras Core. You already listened to many stories this morning, right? So I will just keep very fast, but I will just share some side stories. You already heard many things about the Keras and Keras Core, and I already know that you are using the PyTorch, right? Me too. Yeah. So let's see the backstories. Yeah, Keras Core is the candidate for the next Keras version, the 3.0, maybe this fall. And it regenerate, actually revive the multi-backend support. And you already know the story, right? But is it same as Keras? Because many people know that Keras support the multi-backend, but there is a story. Long time ago, there was Keras. Actually, Keras is a kind of a shell, the kind of a synthetic sugar for the Theano. So it provides a high-end deep learning library, but after Theano, there is a new machine learning toolkit such as TensorFlow, CNTK, and XStat and others. So it just expand to support other backends. Yeah, if you are familiar with this story, you start machine learning maybe more than 6 years ago. At the time, Keras was kind of dominating the field, and it is considered as the easiest solution. And you know that PyTorch came out because PyTorch was not that used because it was taught and written in the Lua, which is not popular for the data scientist. Anyway, back then, the TensorFlow, the first versions of TensorFlow is very hard to use because it doesn't support some kind of debuggability because it's a kind of a configuration generator rather than the programming language. So if you write down the TensorFlow code, it looks like a Python and it runs on the Python runtime, but actually that's just a config generator, and with the session, it just passes the config to the C++ library. So with the code, you cannot print your variable, or you can use the Python debug tools because there isn't, because this is just a configuration rather than code. So PyTorch came out. When PyTorch came out, it is considered as a kind of a toy toolkit because it's very, very slow. Even if PyTorch used the C++ backend, it just copied every process memory to the CPU memory. So you can just see the value of the variables. So you can easily debug. And TensorFlow, that's why TensorFlow grammar is very hard to study. So Keras, when Keras adopts TensorFlow as its backend, Keras is become very, very popular for the TensorFlow users. And as you know, that Francois just joined the Google, and the TensorFlow became the part of the TensorFlow 1.4. And also TensorFlow supports the eager mode, which is the same approach with PyTorch. It just copies the GPU memory to CPU memory by every line, so you can track the variables. Of course, it made TensorFlow very slow. So anyway, yeah. And finally, the Keras just dropped the multi-backend. So it just became the part of the TensorFlow since Keras 2.4. And it just removed every implementation from its GitHub repository. And TensorFlow, it became just the alias for the tf.keras, which is the new implementation for the Keras grammar in the TensorFlow repository, and Keras just provides the alias for the tf.keras. So everybody knows that the Keras is over. But at the time, the François just doing the X, yeah, X, right? It's not Twitter anymore, right? Anyway, he just shared the Twitter. Yeah, it's a kind of a temporary option. So we don't know what happened beneath the water, but anyway, Keras repository became alive again after 1 year. And it just copied the new implementation from the TensorFlow.keras to the Keras repository again. So from TensorFlow 2006, 2.6, the Keras became the independent project from TensorFlow. Before that, to use the tf.keras, you don't need to import the Keras because the Keras is just a part of the TensorFlow. But after 2.6, even though it has the implementation inside, you have to manually import the Keras and install the Keras library. So it's just technically separated again. What happened? We don't know. It's a kind of a dynamics in the big companies, you know. If you are working on the big companies, you just imagine what is happening, what was happening. And after 2 years, Keras was just a kind of a silent, actually. Many people just moved to the PyTorch to develop their model, or just stick to the TensorFlow to use the TensorFlow extended or TPU capabilities and make some the applications. And some just starters just move the transformers library from Hugging Paste to download and just run the model. But this year, Keras is just announced the new Keras Core project. It's completely rewritten. You already heard about the story. So in a long story short, 2015, Keras is released on top of Theano, And Theano just went dead in 2017. And TensorFlow just adopted Keras and just separated after 1 year. And Keras repository is revived and code is completely rewritten, and now it's revived. Why? We don't know. Anyway, we know the only thing we know that is the project size is quite smaller than before because it dropped the TensorFlow 1 support. It just stick to the TensorFlow 2 and other backend. And as you heard about it many times, it supports various merge backend, including TensorFlow, JAX, and PyTorch, and NumPy anyway. But today, my topic is about JAX. So let's go. So the two illustrate about the JAX. I will just introduce some characteristics about the Keras Core to be used for the JAX migration. So the switchable backend and the multi-framework custom components, that's the very important part for the Keras Core, and the universal training loop and native model support and future-proof code. I don't believe that part, but anyway, yeah. Yeah, you can change your Keras backend very easily by just changing the one line or changing the environment variable. But anyway, if you are really testing the Keras Core on your PC, it doesn't work as intended because there are many differences between the backend. For example, if you want to touch as a backend of the Keras Core, you have to really care about the sequence of the input. It's very very strange, yeah. But anyway, actually PyTorch and TensorFlow is different project, right? And it just handle the variable in a very different way, especially when they handle the array, the fundamental architecture for to store the metrics. So if you use if you load some kind of model from the PyTorch, the array structure is quite different from TensorFlow. It's a well-known difference. So if you use Keras Core with a Torch, you have to care about that part. And also, there are many different variable types. Yeah, we are using the Python to use the Keras or other project, but actually, even NumPy, it's not written in Python. It's actually NumPy is written in Fortran, right? Did you know? It's written in Fortran. And Python is used as a glue language to pass our variable to the Fortran-based code. And also PyTorch and TensorFlow has its own implementation, and it has its own variable types. So even if we think the variable is integer, the actual PyTorch engine and the TensorFlow engine handle that variable in a different way and different time. So yeah, even in the very simple integer types, you will have some problems. So be careful when you try to use the multi-backend. And also, if you try to convert your code from the PyTorch and TensorFlow or vice versa, because model compatibility easily breaks up. And also, no sparsity support, yeah. If the metric size is quite big, the most element is usually 0. So it just consumes some memory. So there are many sparse matrix type variable to compress the matrix size. But it's not supported yet because the way to handle the sparsity matrix is so many types. TPU has its own implementation, NVIDIA has its own implementation, and actually the performance metric from the NVIDIA, AMD, and Google, they just made their standard as a sparsity matrix based one. So if you use Keras Core with a multi-backend, you will see the performance difference then announced by the hardware vendors. But I think it will be soon solved. So even though it supports a switchable backend, when you start your Keras Core code, I recommend you to use the TensorFlow at first time. And anyway, if you install Keras Core, it will just bring the whole TensorFlow library here. It just still stick into between the TensorFlow and the Keras Core. It will be separated soon, but anyway, if you install the Keras Core, TensorFlow will be installed together. And there are cross-framework components. So you know that, did you hear about the OPS? Actually, it's a kind of a matrix operations, but nowadays it's used for the machine learning and deep learning operations. So there are many operations for the machine learning. So for example, if you want to implement the full transformer library, you need to at least 140 ops for your libraries. So it starts from the matrix multiplication and summation and stack, Einstein sum and others. And also it has some fused ops to make the computation more simpler, make computation simpler. So yeah, so many hardwares support a different ops set. So you may see the many NVIDIA and AMD GPUs, but nowadays there are many NPUs, and for the IoT device and the smartphone device, and for only inference too. So they have their own ops set to support. So it's very related to your compatibility with your models and the device. Anyway, yeah, Keras ops has many ops inside, and you can use the ops without using Keras architecture. You can just call the Keras ops like just normal functions. So if you already have your PyTorch code, I recommend you to just use the Keras ops as kind of just a function. So you can easily migrate your PyTorch or TensorFlow code. Actually, TensorFlow is already Keras code, right? The PyTorch code into Keras easily. So even outside the Keras workflow, you can use the Keras. This is the biggest difference for the Keras core. If you already heard of the Keras CV and Keras NLP, right? So it's natural language processing and the computer vision. And Keras core's side project work as just a module, not a Keras dependent project. So like you are using the Hugging Face library, you can just use the Keras NLP or Keras CV, like a kind of API modules or something. So this is just an example. So you just to make a custom component, you can just use Keras ops. Actually, the resolution is quite low. Sorry. Yeah, I will upload the slides, so you may just refer the slides. Yeah. So you may make TensorFlow code, PyTorch code, and JAX code, and mix with the Keras ops code to make your own. And also, if you already have your model architecture or structure or something, you can just make it as a Keras model or Keras functions. So we can call it the custom component. So we will make the custom component with the JAX and use it as a part of Keras in the next slide. So, and the universal training loop is when you use the when you try to run train your machine learning model, you have a training loop, right? And there are many training loops, but every framework has its own loop structure and architecture and method. But with Keras, you may use other backend training loop as it's like it's already bundled in the Keras. So to make your custom training loop, you can just call the JAX training loop functions, and also TensorFlow training loop specific functions. For example, only TensorFlow has the gradient tape to train the models, and TensorFlow also provide the distribute functions, right, to train on the distributed clusters with many machines. You can use a TF distribute on the Keras Core training loop, and also if you are familiar with the PyTorch, you can distribute data parallel to make your data sharding architecture or others. So, and if like that, this is the way to use your familiar framework with Keras, but this is for use Keras to your favorite frameworks. So you can just call the Keras layer structure as a part of the torch modules. And also, yeah, Keras is bundling many models nowadays natively. So even if you don't want to use Keras Core, you can just install the Keras Shibuya, Keras NLP, and call the models. So, and also it is used for the PyTorch and TensorFlow too. So just use Keras applications with your favorite backend. So that's the biggest difference. When Keras supported the backend, multi-backend, maybe 4 or 5 years ago, it tended to you write down your code in a Keras format and use the different backend. But nowadays, Keras Core is supporting the vice versa. While you are using your favorite TensorFlow or PyTorch code, you can adopt the Keras libraries and modules when you want to use it. So it's more flexible. So let's go to the real topic today. Is there anyone who are making your code with JAX? Raise your hand. Yeah, no one. Yeah, actually, it's quite normal because it's very hard to explain about the JAX. JAX is made by DeepMind to accelerate their libraries. So I will just share the backstories. Yeah, you know that TensorFlow 1 version is hard to use, so they just apply the many features such as the estimator kind of, but it makes TensorFlow very solid. So TensorFlow was using its flexibility. So if you are using as a production, if you don't have enough knowledge about the machine learning or deep learning, it became more useful. But if you are a researcher, if you try to invent a new architecture or the perceptron types or new layer types, TensorFlow has a very it just forces you to follow its architectural schema. So it's almost impossible to develop a new type of neural net theories or algorithms. So Mind just made a choice to not to use the TensorFlow for the research topics because there are many studies without the conventional layer structured networks. So they made a JAX. Actually, JAX is just started as a high because they just want to make a whole neural net from the ground up. They just try to use the matrix multiplication algorithms to layers or whatever they want. So JAX is started as an accelerator for the NumPy. There are many projects, NumPy or NumPy or other projects to accelerate the metrics management. But yeah, JAX is started as a part, as a NumPy, and plus supports some several ops for the machine learning and deep learning. For example, gradient calculation is always necessary to make your neural net. So instead of coding it every time, they just made a choice, made a decision to import that kind, make that kind of implementation in JAX. So JAX is fundamentally NumPy plus some machine learning ops. So it doesn't support a high-level abstraction or optimization. It just supports calculations, but very fast. That's why it's very hard to explain about JAX. Because if you want to use a JAX, if you have a Python code using NumPy, you can just change it that the import NumPy as a NP, as a JAX.NumPy as a JNP or just NP. You can just replace one line to use the JAX calculation power. So JAX is supporting the NumPy based one, then random number generator and the auto gradient calculations and the vectorization, parallelization. This is required for the distributed programming and the matrix multiplication and the layer calculations. So why JAX? The only goal for JAX is speed, just making it faster, even though it's very hard to use for the high level languages. Actually, JAX is just think like a JAX. Think JAX like a NumPy in place. What? Replacement, yeah. And it's written with the XLA compiler. Did you hear about the XLA? Yeah, many people listened already. Because XLA is some kind of backend for the linear algebra. There are many devices in the world that the CPU. Of course, there are many types of CPUs at the x86 and the ARM-based one and others, and MIPS and others, and also GPUs, but there are many GPUs, and then there are also TPUs and other chips. So XLA is a kind of a linear algebra compiler for targeting the many devices. So if you just write down some algorithm with running on XLA, XLA will compile your matrix multiplication or matrix summarization, other code into the machine-specific code. It's more like a compiler. So it just supports a JIT compilation and ahead of time compilation. Actually, it's a compiler level. So you don't need to care about the hardware itself. It will the goal is to automate the speeding up and optimization for each hardware. So Google just made an XLA for their Android and PCs and the clusters. And nowadays, XLA is widely used for the backend, especially for the TensorFlow and the TPU-based cloud service. And they started the MLIR and as an extent of the XLA. Actually, it's led by the Chris Ratner. He just kicked the Google and Mozilla, right? So it's a part of the LLVM compiler. So if you are familiar with the LLVM, yeah, LLVM. Do you know the LLVM? Yeah, okay, great. If you don't know the LLVM, just remember that most of the language compilers are now run with LLVM. LLVM made compiler making very simple. So anyway, the LLVM just support various ops for the general computation. So if you make a new programming language and run on LLVM, you don't need to care about the hardware. LLVM is doing the hardware compilations. The idea is to add some machine learning and deep learning specific ops to LLVM. So if you if LLVM supports various deep learning ops, you don't need to care about the compiler, the deep learning compiler, right? Because every compiler will do the machine learning optimization. And then if you write down your code in even the C++ or other languages, it will be automatically optimized to the machine learning and deep learning capabilities. Anyway, it didn't work well because the lead just left the Google. So the project goal is slightly changed it, and nowadays the Google is pushing the OpenXLA. The real problem of XLA is it's led by Google. So other companies don't need to follow up, right? So they just change the plan, and they just open the XLA to everyone. So now in the OpenXLA project, the major hardware vendors are joined. So maybe it just wait 4 months ago, I guess. Yeah, so maybe next year we will see how OpenXLA accelerates the every hardware. So anyway, JAX is based on the XLA. So that's why JAX is performing very well, because it automatically compile your machine learning ops in a very fundamental level. So JAX also have an ecosystem. JAX is a LoRa API, you know that. It just supports the matrix operations. So they made a Flex. Flex is based on JAX, because everyone just feel that JAX is not usable for the production. So they just made a TensorFlow-like library again. The community just made it. So to use it easier, right? So with Flex, you can make your code, but Flex is not popular yet. So everyone just use the PyTorch, and Flex has some capabilities for the future, but not familiar and not well documented and very hard to find the example yet. And also, the demand made a haiku, because there is a Sonnet project for the TensorFlow one. And you know, Sonnet is just a kind of poem, and haiku is a poem in Japan, maybe. Yeah, so it's a kind of a high-level API for the JAX too. So the goal of Flex and Haiku is the same. But Haiku just stopped developing anymore, because more and more people are interested in Flex. So they just Haiku became the maintenance stage for this year, from this year. So users are just moving to Flex nowadays. And Optex is optimizers for the JAX. But yeah, I think Sam already shared about the Optex, so I will skip. So JAX has its own ecosystem, but as you see, most of you are just heard about it and first time here. That's why JAX is not popular. And JAX, why you don't know the JAX? Because it's very hard to run. JAX, yeah, JAX is just a NumPy library, right? You have to write down your own code by yourself. If you want to make a layer, if you are using Torch, you can just torch it and lay NN, right? If you are using Keras, you can Keras the layer. You can just call it, right? Dense layer or what convolution layer, others. There's no implementation for JAX. You have to make it by yourself. So, and it's a just-in-time compilation nature. So if you write down JAX code, if you want to do the value of some variable in the middle of your code, usually you just add a print code, right? It doesn't work. Because like TensorFlow 1, it just compiled the whole code and accelerate it. That's why it's very fast. That's why it's very hard to debug. And it's changing so rapidly. especially nowadays, because large language models require heavy optimization, and so the code is just going ahead, but you can find the documentation maybe 6 months to 1 year late code. So if you follow the JAX manual, usually sometimes it doesn't work at all. So Flex will solve the issue maybe soon. Not soon, yeah, because Flex is still hard to run, and it's a independent project, right? You will get familiar with JAX very easily. If you are already familiar with NumPy, you will be familiar with JAX. But to run Flex, you already run the PyTorch or TensorFlow, and adding one more library on your head, that's the problem. And to use the JAX in a production level, I already shared that JAX is now developing very fast to match the performance for the large language models and Gen AI models. That means that JAX is optimized for the distributed workload, more than one GPU, more than one computer. And so if you want to really want to unleash the power of JAX, you will be familiar with the data sharding and device mesh and others. So it's very hard. So how Keras Core solve the JAX problem? Because you just write down your Keras code, and if you want to accelerate some part, you can rewrite it with a JAX code. So you don't need to change the whole code. And even you manage your Keras code, you can just accelerate some part of that. So let's see the example. This is a simple image classification model. Usually, model is looks like this: input definition, and layer structure and output definition. So if you have an input and output definition, you can make up your model, right? Just call the Keras models and give the input and output as a parameters and train and evaluate. That's the very simple image classification example. So this is the real code. So this part is a convolution definition, and this is the input size, and this is the layer structure. You just made the Keras Core layers, layer, just make a layer, and yeah, you can call your models. There are many models in the Keras Core and Keras. So you can use your model. You can just use a CNN model here and compile and just run and evaluate to test. This is just a very common Keras model. You see the difference? The only difference is that instead of using the Keras model, the convolution model, I just use a custom model. So Keras Core supports to make the custom model with your favorite neural-net library, including the PyTorch and TensorFlow, and even for JAX. The biggest challenge when you make a custom model is stateless. Now you know why JAX is stateless, right? Like just a NumPy. NumPy is stateless, right? Just give you the input and you will get output. It doesn't have a state. States including some trainable parameters and the non-trainable parameters such as hyperparameters and the optimizer state. How many times I just ran, or what the epoch number or some kind of state. Yeah, JAX doesn't care about it. It just works like a function. So if you implement the model code, consider the stateless manner of JAX. this is a good news because JAX doesn't support the stateful manner. JAX can receive the parameter and return the parameter as it is or some modified form. So with that, you will just make some kind of lineage control for the state. So you will receive the prior state as one of the parameters and return the next for the next iterations. So yeah, if you are familiar with that, if you become familiar with that, it will be very easy. Okay, so I spent so much time, so sorry. Yeah. So this is a custom model. Custom model just needs three methods. First one is a compute loss and update, and the training and test step. If you implement these three methods, it will be recognized as a custom model in Keras. So yeah, the meaning of each model, I don't think I need to explain about the, yeah, this one. Yeah, this is a loss computation and training and the test. So this is the code for the computation loss. So you call this method the stateless core, which provided by Keras. So by using it, you can just compute the loss using the JAX. In the training step, and you may use the JAX gradient calculation method to calculate. And this is an optimizer stateless supply is also given by Keras. So it's very simple, right? Yeah, even with this implementation, you may accelerate your custom model. And the train step, how can you train the part? So of course, there is a training and calculating the gradient and update the trainable variables for the next iterations and optimize the variable for the next iteration too. And update the metrics for example, the cost or others, and just return for the next iteration. So first of all, the compute gradient, I just have 3 minutes, so let's run. And update the trainable variables and optimize and metrics for the to support the stateless manner. And the test step is to test the gradient cost and determine the next steps. So prediction and loss and metric update and state variable update, and just make some log for the training steps. So, yeah. Okay. Yeah. I need to. I think I speak too much. Yeah. So this is a same code that you saw the Keras Core. So this is just a normal Keras code, but by making that the custom model, by changing this part with from the CNN model to the custom model, you may use the Keras, the JAX capabilities. So you made a model and it's a reusable form. So I recommend you to save your model as a separate file and import them when needed. And also, I will skip the distributed training models. And why you use JAX? It's best. Even though you don't do anything, you will get the 2 times speed ups for your code. And if you run on the TPU, you don't need to change your code for the TPU. The JAX will do the rest. So by combining with the TPUs, you will get up to 10 times faster code. So for the Keras show why it exists, right? Because and JAX now it's a well-documented project. You can just refer the Keras documentation to make some JAX applications. So I have 3 pages, so I will skip very fast. Good point. you can use JAX without hassle. You can just use like a Keras, and you can just choose good ingredient to make your tree bigger and bigger. And also cross data sourcing is very important because nowadays the importance of data is increasing now. And the future proof, Keras code is not changing that much. So if you write down your code in Keras, maybe it will work after 3 years. Think about the Theano and TensorFlow 1 and CNTK. It's very popular 6 years ago, but nowadays you cannot run the code. But if you wrote down the Keras code at the time, you can still run. But the dark side, because if you are already familiar with PyTorch or TensorFlow, why you need to run the Keras again? And with JAX, you will be noticed soon that it's not easy to make a custom model if the model size is getting bigger and if you try to make a distributed model. And actually, Keras make the good code, but actually mixing your PyTorch code or TensorFlow code with a Keras, it will make your whole project unmanageable because every project life cycle is different, right? So maybe it can be a home of the super spaghetti code in the future. So thank you for listening to today's talk. Yeah. I just finished on time, right?